Thank you, Suleiman. You probably can't do that quite yet because you weren't here, but you will be able to very soon, right? All right, number one, sample space. Give me another word that is very similar to sample space, everybody. Outcomes. So that would be naming everything that is possible. So if I said, what is the sample space of flipping a coin, you would say? Heads and tails. If I said, what is the sample space of a spinner that has a 1, a 2, a 3, and a 4 on it? You would say the sample space would be?
1, 2, 3, and 4.
Good. What is the formula, or what is the formula to calculate probability on the count of 3? And we'll start right there. 1, 2, 3.
Number of favorable outcomes over number of possible outcomes.
And because we don't want to write that every single time, I shorten it to favorable over possible. Does that make sense to everybody?
Yeah.
How many favorable over how many possible? Okay, impossible means you have a probability of something happening of
0.
Certain means the probability is going to be
1.
so certain means 1, right?
Yeah.
And that means 100%. 0 means 0%. Yes, no?
Yeah.
Unlikely means it probably won't happen, but it still could.
Yep.
So would you say that in order for something to be unlikely, it has to be under 50%?
Yeah.
And for something to be likely, it probably will happen, but it might not. The percentage would be over 50%.
Yeah.
And if it was 50-50, it would be kind of right in the middle between the two of them. Right? Calculating probability, I gave you this spinner. And I asked you what was the probability you'd spin a 1. And fraction-wise, you all said, well, there's a 1 out of 4 chance to spin a 1, which is 25 hundredths because we converted that to a decimal, which is 25% because we converted it to a percent. You need to be able to convert between fractions, decimals, and percents. We did an entire lesson on this a couple of chapters ago. Super important. Yes, no?
Yeah.
What is the probability of this event? And by the way, do we remember that inside the parentheses, these are called events, right?
Yeah.
What is the probability that you'll get an event that is greater than or equal to 1? 4 out of,
4.
because everything is going to be greater than or equal to 1, right?
Yeah.
All right, this is where it gets really important. Number 8. There's a 45% chance of winning a raffle. 800 people entered the raffle. How many would win? The quicker, faster way to do this problem is to realize that we are simply multiplying 45% by 800 because we're trying to find 45% of. Everyone say of. Of 800 even says right up here, of. So I tell you there's got to be some multiplication in there somewhere, right?
Yeah.
Can you multiply with a percent? Can you actually calculate with any percent?
No.
Therefore, it's converted to a...
Decimal.
Because percents are part of one whole, so to convert a percent to a decimal, it's got to be something less than 1, right?
Yeah.
Can you just move the decimal point 2 places to the... 2 places to the...
Left.
Awesome. Okay, the second way of doing this, and more of my favorite way, is you converted it into a proportion. We knew that there was a 45% chance of winning, right? And we needed to figure out how many of those people are 45%, right? So we kind of lined up the labels, yes, no. We knew that 100% would represent 800 people because there were 800 people in the raffle, yes, no?
Yeah.
How do you get from 100 to 800?
28.
Multiply by 8. So therefore, to go from 45 to X, you multiply by,
8.
yes, no?
Yes.
And then this last guy here, the probability of your stick being drawn is 1/10, right? How often will your stick be drawn per 60 draws? Well, every 10 draws, your stick will be drawn 1 time, right? So for every 60 draws, your stick will be drawn.
6.
How do we get from 10 to 60?
6.
Times 6. So what do we multiply the top number by then? Times 6, right? Is this information needed?
No.
There are 36. It was like nonsensical information. If you were stuck on this problem, is there other ways of figuring it out besides proportion?
Yeah.
If there are 60 draws and you have a 1 out of 10 chance of winning, remember we talked about this? If there's 10 draws, how many times would you win? Once. If there was another 10 draws, how many times would you win?
2.
Once. So the first 10 draws, you would win 1 time, right? The second 10 draws, you would win 1 time, right? If there was another 10 draws, how many times would you win? And if we keep going until 60 draws, because we're at 10, 20, 30, if we keep going after 60 draws, you probably will have won how many times? 6 times. Is that another way of figuring that out?
Yes.
It's kind of like a guess and check method almost, isn't it?